Interactive reading passage, auditory cues, and the ear. Sound is all around us. When something makes a sound, such as a car rushing past on a busy street, the surrounding air molecules move in a wave formation. Because air is transparent, we don't see the wave motion, but our ears can detect it. Eventually, the wave of air molecules makes its way to us and presses against the inside of our ear. But how does this movement of air molecules transform into sound information that we can understand, remember, and use to make decisions? The journey of sound begins with the outer ear, the part of the ear outside of our body that we can see. The shape of the outer ear might remind you of a funnel, satellite dish, or headphone, and there's a reason why. The outer ear is designed to catch and collect as many sound waves as possible, then funnel them into the ear canal. At the end of the ear canal is a thin membrane known as the eardrum. The eardrum is stretched across the end of the ear canal. As sound waves move down the ear canal, they eventually collide with the eardrum, setting off a chain of events inside the middle ear. As sound waves hit it, the eardrum bounces up against the first of three tiny bones called ossicles found in the middle ear. The first bone vibrates the next, which vibrates the third, a bone known as the stapes, which rests against the cochlea, a tiny organ found in the inner ear where the sound receptors are located. The cochlea is a spiral-shaped, fluid-filled organ. When vibrations from the ossicles travel to the cochlea, it causes the fluid to move. The fluid movement activates hair-like receptors, which turn the fluid movement into electric impulses that can be interpreted by the brain. These impulses are sent down the cochlear nerve to the brain, where they are processed as information. The electric impulses that are provided by the cochlear nerve end up in the region of the brain called the primary auditory cortex, a portion of the cerebral hemisphere on the side of the brain. This region of the brain will decode the electric impulses, then compare the sound with sounds from memory in order to determine what to do with the information.